All right, here are the solutions to 1998 calculus free response. These are differential equation problems. This is the first one, number 4. So we've got a function of f of 1 equals 4. That's a point, such that for all points the slope is this. So that means I've got the point is 1, 4, and the dy dx, they said the slope is, but that is just dy dx, right? Right, Matthew?
What?
He wasn't paying attention. That wasn't fair. All right, so in the first part, A, we're supposed to find the slope of f at the point where x equals 1. Well, that couldn't be easier. dy dx, that's the slope function. We've got the point, 1, 4. So that's 3 times 1 squared plus 1 over 2 times 4, which is 1/2. Right? To find the slope at a point, given this kind of thing, we need to know both the x and the y coordinate, but they gave us both the x and the y for that. Part B, write an equation for the tangent line. To write the equation for a tangent line, we need a point, which we have, 1, 4, and the slope, which we have, which we just found, it's 1/2. So that would be y minus 4 equals 1/2 times x minus 1. That's in point slope form. Or I guess you could move the 4 to the other side. So that's y equals x minus 1 plus. Maybe look like this. There's the equation for my line. And then they want us to use that to approximate at 1.2. So that would be 1.2 minus 1 plus 4. That's equal to, this would be 0.2, which is the same as 1/5. So that would be 1/10 plus 4, or 4 and 1/10, or 4.1. All right, so there's our approximation. Part C. Find f of x by solving. Okay, so now they want us to solve this with the same initial condition, f of 1 equals 4. So let's see, that means we have to separate our variables. So I have 2y dy is equal to 3x squared plus 1 dx. Take the antiderivative of each side of that. Antiderivative of 2y is y squared, equal to 3x squared, that's x cubed, plus x plus c. And the solve for c, I think I'm just going to leave it like this. Before I solve for y, I'm just going to go ahead and figure out what the c is. So I'm going to plug in 4 squared equals 1 cubed plus 1 plus c. So I think c is going to be equal to 14. So that means I have y squared is equal to x cubed plus x plus 14. And solving for y, that would give me y equals plus or minus the square root of x cubed plus x plus 14. But we can't have a plus or minus there because that wouldn't be a function. So we need to figure out, this is supposed to go through the point 1, 4, right? So if I plug 1 into this, 1 plus 1, 14, the square root of that is 4, that it would give me I want the positive version of this, right? If I had the minus, that would give me negative 4. So that is the right one. Not with the plus or minus, it's the positive one that we want. And last, in part D, they want us to use that to find the solution, the actual solution, or actual value, I should say, of at 1.2. So y at 1.2, or f at 1.2 if you want, would be equal to the square root of 1.2 cubed plus 1.2 plus 14. And this is back in the old days when this number 4 would have been with calculator, so you can figure out what that's approximately equal to. And I don't have a calculator handy, so I'm not going to do it. All right. Number 6 from the year 2000. only two parts. That means there's going to be a big solving differential equation part of it. So I've got this differential equation. dy dx is equal to 3x squared over e to the 2y. And first part is solve it with the initial condition 0, 1/2. All right, so let's get busy and do it. So I got e to the 2y dy is equal to 3x squared dx. I'll integrate both sides. The antiderivative of e to the 2y is 1/2 e to the 2y. Make sure you understand why that 1/2 is there. Antiderivative of this is x cubed plus c. Now, before I try to do any natural log business, I'm going to get this to the other side. So that's e to the 2y is equal to 2x cubed. What happens to the c when you multiply by 2? It's still just c. And then take the natural log of both sides. That gives me 2y is equal to the natural log of 2x cubed plus c. Right? And means that y is equal to 1/2 times the natural log of 2x cubed plus c. And I know this is supposed to go through the point 0, 1/2. So somewhere along the lines I have to solve for c. I guess we can just do it here. So when y equals 1/2, it's equal to 1/2 times the natural log of 2x cubed plus c. Right? And oh, this is 0, isn't it? Sorry, times 0. So that just looks like that. So that means the natural log of c must just be equal to 1. So c is equal to e, which means I have y equals 1/2 natural log 2x cubed plus e. Looks like that is the function. Now, in the other part here, part B, I'm supposed to find the domain and range of this. It's a little bit of an unusual College Board question, but we could do that. What's the domain of this? Well, what values are we allowed to plug in here? We're only allowed to plug in values into this natural log function that make this greater than 0, right? I need 2x cubed to be greater than 0. 2x cubed plus e to be greater than 0. So that means x cubed must be greater than negative e over 2, and x must be greater than the cube root of negative e over 2. That's the domain. The range, well, let's think about this. What's the range of the regular natural log function? The regular natural log function looks like this. And although it starts to grow very, very slowly, it will forever keep going up. Oops, you can't see that, can you? It will forever keep going up, and it will, the range of this, the domain is x is greater than 0, and the range is all real numbers, right? All reals. So here, the question is, are there any values that this can't take on? If this can take on any possible value, then the natural log of this will also take on its full, the full range of the natural log function. And since this has an x cubed in it, this can be anything, right? If you think about what 2x cubed plus e looks like, that's like a cubic like this that can take on any possible y value, right? So we're plugging in anything into this, which means that the range is still just all reals. Or you can write it like negative infinity to infinity if you want to do it, and you could have done this one in interval notation too, if you like. And that's it. How about that? 2 15-minute free response questions in less than 10 minutes.